Dioxin is a general term which describes a family of 219 toxic chemicals that are highly persistent in the environment. It is a contaminant formed in industrial production, usually from combustion sources such as incinerators. It also is present in metal smelting and refining and process sources. Due to its persistence, it may take 9 to 15 years to degrade to its half-life concentration, and below the surface, it remains largely unchanged even over time. The excess waste from obsolete electronic devices, such as refrigerators or phones, generates somewhere in the range of 41.8 million tons annually. Compounds of a dioxin-like nature reveal themselves in small particulate matter that have severe adverse effects unknowingly to the person or animal being harmed. It is resulting in cancer rates and mutations of immense proportions, and countries are beginning to legislate to combat this issue, as more and more research has been done over the past few years. An issue of great concern in the management of e-waste is with the pollution emitted to the surrounding area. Compounds in the surrounding area of e-waste processing plants were found to be accumulating in great densities, as well as further away, which is due to the compounds being transported slowly over time due to wind and other environmental factors. The management of e-waste is important as much of the material can be recycled for future use. Although several countries, including China, have implemented legislation focused on the disposal of processing of e-waste, the problem of pollution has not yet been resolved. Groups using chemical-activated luciferase gene expression, toxic equivalency factor, or Calyx-Tex, and World Health Organization Toxic Equivalency Factor, or WHO-TEX scales, reported findings of dioxin levels in locations near processing plants to be far greater than the maximum acceptable level, and various other groups have been conducting studies in order to see what degree dioxin pollution is present and how it affects the environment and the local population. A study was conducted in the village of Bui Dao in Vietnam, using a sample area of living areas and rice fields that encapsulated about 4.2 kilometers of land mass. Their findings in soil collected from this area, which was located near an e-waste processing plant, were that dioxin levels tended to be 1 or 2 magnitudes higher than the average, based on a scale developed to measure soil toxicity. One of the factors contributing significantly to the abundance of pollution is due to the illegal dumping and burning of tires, plastics, and other materials that have contributed to major health concerns. In the region of Campania, Italy, adverse health effects have taken place due to the mismanagement of e-waste. Studies have provided proof that there has been an increased risk of liver and lung cancer. Sheep in the surrounding areas were found to be contaminated by exposure to dioxin, which has presented itself in the form of higher rates of chromosome fragility, high rates of mortality, and an increase in abnormal fetus development. Tests for dioxin in the milk of the local sheep and cattle exposed that about 1/4 of them have dioxin levels much higher than the average that the European Commission considers acceptable. Campania has also been experiencing increases in death due to cancer, and when compared to the national statistics, their rates of mortality per 100,000 people are significantly higher. One of the methods of eradicating waste that contributes towards these problems are solid waste incinerators. Incineration is a waste treatment process that involves the combustion of organic substances contained in waste materials. Incineration of waste materials converts the waste into ash, flue gas, and heat. They may reduce the physical amount of physical waste, but they contribute towards an immense increase in global particulate matter in the air. These compounds are harmful once inhaled, ingested, or when in contact with skin, and contribute towards a wide range of mutations and cancers in humans. A study was conducted in a city in Sweden that estimated that an incinerator contributed between 17% and 32% of urban particulate matter. Due to dioxin-like compounds operating at high temperature, the effects are inflammation, an increase in blood viscosity, and a distortion of delicate cell functions. Studies have shown significant evidence of soft tissue sarcoma and non-Hodgkin's lymphoma in areas of significant dioxin exposure. Locations which have the greatest concentration of these compounds have shown immense increases in breast, gastric, and colon rectum cancers, with an increase from 7% to 17%. Economic feasibility is greatest when employing the method of incineration, because the simpler treatment path contributes to economic convenience and benefits regarding the treatment cost, and the sales profit and fuel substitution effects are excellent when the incineration residual heat was sold. As consumers toss aside old cell phones, tablets, and laptops to keep up with the latest technology, landfills are becoming full of the old devices. To address this buildup, scientists are attempting to recover valuable plastics from this electronic waste with alternative strategies to incineration. In 2009, U.S. consumers discarded 2.37 million tons of e-waste, according to the United States Environmental Protection Agency. In an effort to reduce the amount of e-waste accumulating in landfills and recover the valuable polymers, researchers have explored different extraction methods. Now, one group reports in the American Chemistry Society Sustainable Chemistry and Engineering that they have found an eco-friendly alternative to current methods. Current approaches can include the use of chlorinated substances such as dichloromethane that are toxic, pricey, and volatile. Scientists want to explore an alternative solvent called N-methyl-2-pyrrolidone that would be more friendly to the user and the environment, which may possibly serve as a practical alternative to the current approach. Cell phone plastics typically contain a mixture of polycarbonate and polyamide. In large scales, the researchers found that DCM and NMP recovered 87% and 89% of the polycarbonate from cell phone plastic, respectively, and the NMP could be reused at least one more time without losing efficiency. But some e-waste contains more complex mixtures that would require multiple solvents and a lot of energy to recycle. In that case, scientists suggest that pyrolysis or heating the material to high temperatures would be a better alternative. They showed that the amount of a mixture of 4 e-waste plastics was reduced by about 40% with pyrolysis. Pyrolysis may actually be one of the best future alternatives to our current incineration process. Pyrolysis is a thermochemical decomposition of organic material at high temperature in the absence of oxygen. It involves changes of chemical composition and physical phase. In the pyrolysis process of organic material that is a part of electronic waste, it is decomposed to molecular products that can be used, for example, as fuel. Pyrolysis of organic materials produces gas and liquid products and leaves a solid residual rich in carbon. Proportions of solid, liquid, and gas yields depend on material that is pyrolyzed and process conditions. Pyrolysis can be considered as an alternative method of recycling electronic waste because during the process, organic content of waste is decomposed to product that could be used for energy recovery. In addition, pyrolysis significantly reduces the volume of the waste, which is beneficial for further treatment. The combination of mechanical methods, pyrolysis, and chemical processing could increase efficiency of electronic waste recovery. The global concern for the reduction of pollution is an issue of great magnitude. The evidence has shown that it has had serious effects on animals and humans. The fact that dioxin levels and increases in mutation and cancer seem to have a correlation exposes the depth of the pollution problem. This is an issue which has both environmental and humane byproducts that I feel should make this product one to be taken heed of by members of the medical community, technology industry, and government and their constituencies, as it will have residual effects that could affect the current condition of our world. Countries have taken action, but more needs to be done, both legislatively and in regards to research, so that harmful effects of dioxin compounds can be significantly reduced. Finding alternative methods for the future that are more in tune with efficiency and environmental consciousness, such as with pyrolysis, need to be promoted and researched further as the global levels of production continue to increase yearly, which inevitably will produce greater and greater quantities of e-waste.